is for the submission of assignment 1 for advanced engineering mathematics. I am Engineer Summer Cablinda, and this is my presentation. So before we begin with our uh, differential equation for the physical system, let's have a short background for our system. So this time I'll be presenting you the dynamics of a simple structures and the formulation of the mathematical model of a single degree of freedom system. So we have here a one-story building, a single-story building, especially shown here on the left side of the screen. And these are will be idealized as a single story structure or a simple structure. So when we say simple structure, these are structures that can be idealized as a concentrated mass M, like here we have the mass on the roof with a column of stiffness K. So, mana siya. So on the left now we have a single story building and also a water tank. On the right side of this screen, we have a one-story building. So what is this? So before we proceed with our mathematical model, no, in order for us to obtain the mathematical model, we need to simplify and idealize the single-story building. So we have here kaning idealization nato for a single degree of freedom system. So nganong single degree of freedom system man kay ato lang siya i-allow to move sa usa ka direction. So in this case ato lang siyang i-allow na move siya on the lateral direction. No? It's either to the right or to the left. But to obtain that one, natay mga needed nga i-consider or i-apply nato to idealize our system. So for here, first one, we need this one. The structure is resting on a rigid ground. So pasabot, ang column is fixed to the base. Another also, we have a rigid roof. So atong to have a single gear freedom system, dapat ang roof is rigid. Why? Because let's say we have a building dire, no? Now, let's say we will apply a dynamic loading here, no? P of t. So we are dealing with dynamic loadings in the single degree of freedom system. Now, if mag-apply kag dynamic force diha, and then if the roof is not rigid, so probably the roof will deform, no? Something like this. Ang itsura sa structure might look like that one. Now, what will happen? So, di ba dapat ato ang goal is the single degree of freedom lang. Dapat usa lang ang yaang movement. Now, if tan-aw nato ni nga move, usa man nahitabo niya, ni ba? Ni move siya to the right and ni move siya downward. So, pila naman naka movement? That is already duha na. And also, naapod tay rotation involved ani if the roof is not rigid, di ba? So that's why one of the assumption good is that the roof should be rigid. Next is, so nato assumption is that the column is flexible, but take note, it is only flexible in lateral direction, but rigid in vertical direction. So nganong flexible in the lateral direction? Para mo makamove siya sideways. And then rigid in vertical direction, para like in this case, no, dili siya mo kanaog, like in this case. So mo na siya to ang assumption in order for us to have a single degree of freedom system. And aside, the column is also massless. So that's why we have the column here, no, mura na siya naka-stick. And then the rigid roof, we have our mass here. So that roof, that building will allow that to move on the lateral direction. So iyang movement on the lateral direction kibali ni deform ang building by application of load. Atong i-denote ang deformation, no, the lateral deformation, let's denote that as U of t. So actually we can use S, di ba, X or unsa pa to denote the movement or the deformation of the structure. But this time let's denote it as U of t. So pasabot, the deformation is varying through time. So anything here, this is the dynamics of simple structure. Sa ato pa ang force is also varying through time. No, the deformation is varying through time. The velocity is also varying through time. The response acceleration of the structure is also varying through time. So moving on. Okay, so let's say no katong one story na to nga building, let's say ato siyang i-move. So we have our initial displacement no at time is equal to 1 initially atong displace ang structure nga with a deformation of u naught. Now, ang column ni building na siya ginatawag natog stiffness no, lateral stiffness. So kung nakay lateral stiffness or let's say stiffness, this is stiffness. Ang stiffness, that is the capacity of the structure or material to what? To resist deformation. So si column is na siya stiffness, ato pa, pag ato siyang i-deform og U-knot, i-resist na ni column. And because of that, na-day tayo resisting force. Let's say no, our resisting force, let's denote that as our Fs of T. So it also changes through time. So let's call this our elastic force or elastic restoring force. So kani si stat or static force also. Ang iyang formula na ana is negative K times the deformation nga si U of T. So for our example here, atong deformation is U naught. So if we multiply that with our K nga stiffness, it will give us the elastic restoring force nga presently column. So nganong negative man? Because the elastic restoring force is always opposite the direction of motion. So kasabot, kung towards the right ang motion, si force po towards the left kay nga naman iya mang i-restore or ibalik sa original position ang ato ang structure. So here, gi-displace na to si building initially with U naught. Yeah, by elastic restoring force, iya nang ibalik sa initial position. Unya kay ang elastic restoring force iya magibalik sa original position pero wala man say mo kuha na mo dissipate sa energy mo padayon na siya og sway on the other side. So nanapod tay deformation. And then elastic restoring force ibalik na pud niya ang building pero mulahos ra gyapon na siya sa pikas. No, this is the structure if we have the mass and also the stiffness of the structure. Now, may tabuan ni perpetual na ni siya nga motion, no? Kay wa may gapugong. So, kung imo na i-graph, this is the graph of the kuan, the deformation or displacement of the building through time. Initially, at time 1, natay deformation nga yun not, and then at time 2, nibalik siya sa original, but nilaw siya sa pikas direction, and then so on and so forth nga direction. So, this is perpetual. Nga niyang mahitabo, if ang ato ang system is only mass and we have the flexible column. Now, saan man na nato in real life, this is not existing. So that's why natay idugang no kato si damper or viscous damper. So unsa man ning dampers? Dampers are energy absorbing element. So mo na din siya. So di ba natay lateral we have the elastic kuan restoring force. So napag ito actually inertial force ani. So after ana by the kuan addition sa damper. So ang damper kaning viscous or kuan energy absorbing element nato, it might be just the structure itself for real structure gyud. Ang structure is if mo undergo og vibration ng structure dili gid na siya forever and ever mag-vibrate. No, mohunong gid na siya. So that's why we apply the concept of damper here. So naanatay aron naanatay mahimong functional elements of a single degree of freedom system. At least idealize siya, simplified, but duol-duol sa realistic. So mo na din siya. We have an additional damper with a coefficient C. So moto no, we have the mass of the structure at the roof. We have also K. It denotes the lateral stiffness. And we also have our synadion. This is the coefficient of damping. Okay, let's proceed. Okay, so man ito ang model, no? So we have our dynamic force diri. Mo ni siyang applied force na to. And then, as you can see, no, that is P of T. So that also varies through time. So we have our mass, we have our lateral stiffness of the column, and now we have our applied nga kuan, damping, no, sa itong structure. Now, if you look closely, if we make a free body diagram of our structure, natay mga forces nga ma-involve ana niya, di ba? We have here inertial force. This is inertia force. Mo ni giingon ni D. Alembert. That is equal to negative mass times the acceleration, di ba? We have also the static force katong giingon ako ganiya. That is equal to negative k u of times u of t. And we also have our damping force. Unsa man yung damping force? That is equal to negative c times the response velocity. So you can see here, no, we have also our deformation. Don't forget that our deformation is just u of t. So you have our u of t here, and if you differentiate u of t, natay du over dt. This is our, or let's say that is, let's represent that by u dot of t, so the first derivative of u. This is our response velocity. So anong response velocity man, kay mo man ni ang response ni structure, ni building, man ang response velocity. Kung ato pag integrate, so we'll have a second derivative of deformation. So again, no, this is the lateral deformation. And kung ato siya second derivative pag yun, u double dot of t, we will have our response acceleration. And then we have our our I here, this is just a kung ano ka ng unit vector lang. Because the force here, the dynamic forces that is present in the structure are in vector quantity. Though we can convert them into a scalar quantity. Okay, so moving on, we have here the four, nati upat ka forces no nga gaak sa atong building. We have our external dynamic force represented by P of T. So mo na tong gi-present kaniya. We have also our inertia force. Ato nang i-represent by Fi of T. So mo to siya si negative m mass times the acceleration as mass acceleration, or negative m times u double dot of t. So u double dot, that is just the mura siya u prime. No, aron di ta malibog. Mura siya u double prime. Pero u double dot lang itong gigamit. We have also our damping force, which is equal to negative c v of t, or response velocity, or negative c u dot of t. And our elastic restoring force, Fs, represented by Fs, that is equal to negative k u of t. So mo ni siya ang forces nga gaak sa atong structure na. Okay. Yung anong negative man ni si kuan, inertia force, damping force, ug elastic restoring force, it is because they oppose motion, no? They try to restore and resist the motion. So si damping dapat opposite yun ang direction sa motion, kaya mang ipahunong ang atuang structure. Okay, structure. Now, by applying the dynamic equilibrium nga concept ni kuan ni D'Alembert, ingon siya, no? So we will have equilibrium, ato ni siyang ikuan, no, equate to zero kani tanan forces that acts on the structure. So let's say we have our dynamic force plus our inertia force plus the damping force plus F of S, the elastic restoring force, plus P of T is equal to 0. So we will have here a dynamic equilibrium. Isa-substitute lang nato ni si inertia force, that is negative M times the second derivative of U of T plus, that is not plus, that is minus. Minus man ni sila. Minus C times the derivative of, first derivative of the lateral deformation. Minus the K times U of T, or lateral deformation, plus P of T is equal to 0. I-rewrite na to na into standard form. We will have mu double dot of t plus cu dot of t plus ku of t is equal to p of t. As you can see, this is in this is in the form second order linear non-homogeneous ordinary differential equation. So we call this our equation of motion. So si equation of motion mo ni siya ang mag-describe sa behavior ni structure. So from a physical system, di ba, we have a physical system atong one-story building. Ato din siyang gibuhatan og mathematical model to describe its behavior or its motion. So after ani, we'll have our solution and also the interpretation of our solution. So in the next video, I'll show you the step on how to obtain a general solution sa atuang equation of motion.